Hello again. This is chapter 13 video. Probably I'm gonna have to do two videos, but I hope you're doing well. So let us get started. Let's see. So we are going to talk about sequences and series. First, we're going to start with a kind of a definition. We understand what series and sequences are. First, we start with sequences and we get to series. A sequence, as the name suggests, is just a sequence of numbers, right? So for example, 1, 2, 4, right, 5 is a sequence. If you put it in a set notation like this, that's a sequence. It's a finite sequence because it has finite number of members, and the members are called the sequence has terms, so the members are called terms. So this one is the first term, second one, second term, third term, fourth term, right? So the way it works is that we have some kind of function, we call it a sub n or f of n, and this n here is an integer. It's not a real number, it's an integer. So you don't find f of, for example, 1.5. It's only the positive integer. Sometimes we use 0, but in general, no. So f of n is a formula if there is one. If there is no formula, then we just have to have, the members here or the terms, and that's the sequence. All right. So this one right here is a sub 1, a sub 2, a sub 3, a sub 4, and so forth. Okay. So a few properties of sequences, characteristics of them. A1 is the first term. A sub n is the nth term. So when I say a sub 3 means the third term. And I say a sub 2, it means the second term. And I put a sub n means nth term, right? All right. A sequence can start with a sub 0. Domain includes 0. Most of the ones we're going to work with in this chapter, they start with 1. An explicit formula defines the nth term using the position of the term. So if we have the explicit formula, for example, let's say somebody says, I want to define a sequence that is basically 2n plus 1. So this sequence will be, the first term would be when n is 1. So that would be 3. And then the second term is when n equals to 2, which is 5. And so forth, right? Now, if you don't tell us whether we should stop at certain number or not, then we keep writing it, right? So we can also put a comma here and put the nth term is 2n plus 1, and then continue with the dots. So this right here, this whole thing, is a sub n, right? And so forth. So this is an infinite, actually, sequence. If we stop at certain n, then that's a finite one. So the explicit formula defines the nth term using the position of the term in the sequence. So this one, you want to know what it is, you have to put 2 for n because that's the second term. A sequence can continue, of course, forever, and that's an infinite sequence. All right, so let me clean up this mess here and move on. So write the first 5 terms of this sequence. Well, that's easy, right? You just put n equals to 1, that's 5. N equals to 2, that's 2. N equals to 3, negative 1, and so forth. And then you list them in order, right? Because that goes the first one. The position matters. So this is when n equals to 1. This is when n equals to 2, n equals to 3, n equals to 4, right? And this one, n equals to 5. Okay. All right, so now can we work with sequences with calculator? And the answer is yes. So here we go. what if you have a formula like the one we just had, right? Which is that one right there. So what we do, first of all, you go to mode and change the mode of the calculator that usually is on function when you do algebra and other things with it, with functions. We're going to change it to sequence and press enter. Now the difference now is when you go to y equals 2, you don't see what? You don't see y1, y2. You see two things here. Now first of all, this one applies to all of them. So n equals to, what's the minimum n you want to start with, right? If you go down, you see what you have is what? You have 1, 2, and 3 sequences you can graph at the same time. There are 3 of them. Remember with y1 we had 10 of them. Now, there are 2 different ways we can define a sequence. This way is just we have a formula for it, so we put it here on the first one. U sub n is negative 3n, negative 3, and when you press x, you get n instead of x in sequence mode, so plus 8. Now, you want to graph it, you can graph it, just set up your window, make sure your window fits the points, the points fit the window. So, n min means what do you want to start with? It was over here too. So you have to start with what number do you want to start? We want to start with 1, okay? And then we go to window. So it says n min and n max. So we want to go to 5, n equals to 5, right? So min and max is 1 and 5. Now step is plot start. Plot start means you want to start in theory from n equal to 1, of course, in your sequence, but you only want to graph maybe 2 of them. So you want to start from 4. So you can put 4 here, and the graph starts when n equals to 4, and then you have only 2 points. And the step is, let's say you want to only graph, you want to start from 1, but you want to go by 2 and graph it. You can do that too. If you don't want that, just leave these as 1s, right? And then we come down and we have to have enough room in the horizontal axis and the vertical. So horizontally, we really need to go from 1 to 5, but we're going to go to negative 1 to 11 to have enough room. And then step is 1. The scale is 1. And then for y, we might get a negative answer, so let's go from negative 10 to 10, and then graph. And you see the points right there? Now, what if you want the actual values? Well, you can go to table set and set your table from 1, step 1, and make sure it's auto, and then go to second table, and right there. So these are 5 of them. These numbers are actually the same as the numbers that we have here. When n is 1, u of n is 5, and so forth. Now, what if you want to get them in one list, right? You could do that too. So the way it works is this. You could go to second list and go to operation and pick that number 5, which is the sequence. So you create a sequence with this formula. So first goes the formula. So we're going to put the formula there, negative 3n plus 8, comma. So this works like this sequence command. First you put your u of n here, u of n or a sub n or f of n, but here we call it u of n. And then we put the variable that is there, n, and then you put lower and then upper. That's it. So we put n and then 1 and then comma 5, right? Now you can press enter, and here you go. It gives you a sequence with all the members in it. Okay. Let me clean this mess here. So that's the idea of a sequence. Now notice that there was something else in there that it says u of n min. You have to leave that blank for now. We get to that in a second. We don't need that. If we have explicit formula, like in this case, we don't need that. If we have recursive formula, we need that. Okay, so let us do another one. Now notice when you find the terms of this, it's got that -1 to the nth power. Now remember, n is an integer, so if n is odd, we get -1. If n is even, we get what? We get 1. So that means it doesn't change the value of that term, but it changes the sign of it. So when n equals to 1, we're going to get a negative answer. And then, of course, the rest of the formula determines what value we get. And the second term would be positive, and then negative again, and then positive, then negative. So it looks like the signs alternate, and this alternating signs is caused by that term, by that part of the term, by that part of that structure, -1 to nth power. All right? So again, can you do that with calculator? Yes, you do it with calculator. So we want to do it by hand right here. You want to do it with the calculator, you could just put, instead of that, you have to put this formula, which is, now you have to make sure you put numerator by itself in parentheses. That's -1, right, to the power of n, and then times what? Times n to the second power, and then close the numerator, and then divide it by another parentheses for denominator, which is n plus 1, and we are done. Now we can do the same thing. We can go to table, and you see the values, but they're not fractions. What if you like them in fraction form? Then we go to home screen, we go to list, just like we did before, operation number 5. Now I don't want to retype all that in here, so what I do, I use something called u of n, which is the same as y1. Remember, when we have functions, y1 here is actually the same as the function you put there. So for sequences, it's called u of n, and this u is not the letter u here, is not that one, is this one right here, see? So what we have to put there is second, number 7, that's u, and then put u of n. So when you put that, calculator automatically is going to go pick that one for your function, because we already graphed it once, typed it in once. And then the structure is the same, comma n, comma 1, comma 5, right? And press enter. Well, we don't get fraction, but you go to math, convert to fraction. See, you get the same fractions that we got here. All right, so that's how you deal with that. And here's another one. I'm gonna let you do that yourself. I talked about the fact that -1 to nth power causes the alternating signs, right? And I'll give you the answer for this and see if you can get this with calculator and without both. You can stop the video and do it with your calculator and do it. Make sure you can get it. All right, here's another one which is like a piecewise function. Here it says a sub n has two formulas. If the number n is not divisible by 3, use this. If it's divisible by 3, use this. So we start with n equals to 1, then I'm going to have to use this. So 1 squared is 1. when n is equal to 2, when n equals to 2, 2 is not divisible by 3, so I put 4. When n equals to 3, well, 3 is divisible by 3, so I use this one. So 3 over 3 is 1. And when n equals to 4, I have to go back to that, because 4 is not divisible by 3. So that would be a 4 squared, which is, 16, and so forth, right? All right, so that's the idea of this, and that's what you're going to end up having. 1, 4, 1, 16, 25, 2. All right, so it's possible to have a sequence that doesn't have just one single formula. It changes depending on the domain. All right, so write an explicit formula for the nth term of the sequence. It's not always easy to do that, but this is not that hard. The signs are alternating, so there has to be a -1 to some power. Now, if they start with -1, if we start with negative and then go to positive, this will be n by itself. What if this was positive, this was negative? Then we have to start with n minus 1 or plus 1. So when n is 1, you don't get a negative, right? But in this case, we do want to get negative when n is 1. So we put that. Now, what about the numerator? Remember, we have to determine these based on their position. So this is the position of n equals to 1, and we are getting negative, which we already know why we got negative. And then we are getting 2 and 11. So we know this part of it, right? That's that. Now what about 2? How do we get 2? Well, 1 plus 1 is 2, so that should be n plus 1, right? How do we get 11 out of n? Well, what do we do to n to get 11 when n equals to 1? Well, if you do it for these two, you get the pattern. The pattern is 2 times n plus 9. So that's the formula. As I said, it's not always easy to do this, but that's just to practice with sequences. That's what you get. All right. So there are some sequences that is not easy to write explicit formula for them. So we write something we call recursive formula. So recursive formula is basically, we're going to see how we can get the next term using the previous term. This one is 1, 1, so there is no way we can find a pattern here. So we're going to let this be A1, let this be A2. So here, let's say A1 is given, and A2 is given. So we start with n greater than or equal to 3, and the way we get the rest of them is this. Let's look at it. You see, the way you get 2 is to add the previous 2. To get 3 is to add the previous 2. To get 5, add the previous 2. 8, add the previous 2, and so forth. And so forth, right? So that means here I could just do, so if this is a sub n, the one before that would be a sub n minus 1. The one before that would be a sub n minus 2. So the formula should be a sub n minus 1 plus a sub n minus 2. So that's called the recursive formula. And we can actually, if you have this, everybody can find all the terms of this sequence. And it's, by the way, a famous sequence is called Fibonacci sequence. Fibonacci was a free thinker during the Dark Ages. He went all over in Spain and Middle East and brought algebra to Europe. He wrote a book called Liber Abaci, which means book of calculations, and introduced Europeans to algebra in 1103, I believe. All right, so let's continue here. Write the first 5 terms of the sequence defined by the recursive formula. So we got a recursive formula when when we have recursive formula, we have to be given A1 because we built the rest of them based on that, right? So we have to be given. In the previous example, we had A1 and A2. So here we have to have A1. So we are given A1, and then A sub n is basically do something with the previous one to get the next one. What do we do to the previous one? Multiply it by 3 and subtract 20. So we can easily get A sub 2 using this formula. Multiply that by 3 and subtract 20. So we get 7, right? And so forth. So that's called the recursive formula, and you can easily find these numbers, right? Now, can you use the calculator with this to get this? Yes. That's why we have that part that we left blank, right? So when you go to sequences, you press y equals 2. Instead of putting the formula, one formula here, here's what you do. You start with 1. The formula is going to be that formula, right? Now, this right here, the calculator is going to think of that as u of n minus 1. So that's our function, but we don't have a function explicitly given like previous examples. Here we have to do something to u to get the next term, and we start with the term already. So this that we left blank here last time is going to be 9 now. What does that mean? It says, what is the u of the minimum that you put there, which is 1. So we start with n equal to 1. But what is that term? That term is 9. So we put it here. And then in where we put the formula, we're going to put this whole formula right here. Except for what? Except for we don't put a sub n minus 1. We put u of n minus 1. U of n minus 1, not subscript. So where do we get? So we put 3 and then times what? Now where do we get u? Well, last time I told you, u is right above 7. You have to press second to get it. Don't get that u, the green one here. This is the u we want. So u of n minus 1. And then close parentheses, minus 20, right? Now we can find all of these numbers right here. You can go to table and find them right here, you see. The first one is 9, second one 7, and then 1, right? See it here. Negative 17, negative 71, and so forth. Or you can go to home screen, just like we did last time. Go to list, operations, number 5, the sequence. Now the formula is already in u of what? The formula is in u. So you don't have to put the whole thing here. You just put u of n. So u of n. If you entered it already there in y equals to, you don't have to enter it again here. Just put u of n. This u of n is not u of n minus 1, right? By calculator takes the whole thing to be our u of n, right? All right. So you put that and put comma n, comma, let's say 1, and stop at 5. And enter. There. See? These are the 5 members right here. Okay? So see if you can do this yourself. Practice with this. Here is another example. It says write the first 5 terms of the sequence defined. Well, I just did it for you with the calculator, right? So you can stop the video and go through the steps on the calculator. See, make sure you can do it. use factorial. Factorial is an operation that is very useful, especially in probability and statistics. So n factorial has a definition. It's basically a multiplication. So 4 factorial means 4 times 3 times 2 times 1. That's 4 factorial. 5 factorial, you start with 5, subtract 1 until you get to 1, and then multiply. N factorial, you start with n, subtract 1 until you get to 1, and then multiply. Now, I'll put n greater than or equal to 2, but it could be even 1. So we can just say get 1 out of definition here, because if n is 1, you're already at 1, so you stop. But the question is, how do you multiply one number by itself? It's kind of, you can define it to be 1, and then 0 factorial also is 1. So these two are given, let's say. 1, 0 factorial, 1 factorial, they're just 1. And then any other number, integers, right? Remember, positive integers. In more advanced mathematics, you can actually take factorial of real numbers too, but that's a different story. Here, we just mean integers. So you take the integers and do this to them with one integer, but then you create more integers and you multiply them. All right. Can you do factorial with the calculator? And the answer is yes. Where is it? Well, it is right here. You go to home screen. Let's say I want to do 12 factorial, right? So I press 12 first, then I go to math, and then go to probability, and get number 4, which is factorial. And then press enter. There, that's a big number. In fact, factorial grows really, really quickly. So if I do 70 factorial already, the calculator cannot do it. See, it gives me an error message. So up to 69 factorial, calculator can do, which has what? 98 zeros here. Now you have to move the decimal 98 places to the right. And the calculator cannot do more than 10 to 99, so it's going to stop right there and say, no, I don't have any space for it. Overflow means no space, right? All the cells are filled. All right, so write the first 5 terms of this sequence. Well, this sequence has factorial in it, so you have to use that idea. You could also put it in a calculator. Calculator finds the sequences, the terms for you, right? But it's better to practice with this and do it yourself. So I'll let you do that. This is the formula, n equals to 1. You put it there and find it. N equals to 2, you put it there. See if you can get the same numbers. And you can check your work with the calculator. All right, so we're going to talk about the special kind of sequence that's called arithmetic sequence. Arithmetic sequence is when the terms are given in a way that if you start with the first term, you keep adding or subtracting the same number in order to get the rest of them. So in this case, if you keep subtracting 3,400, you get the next term, right? So it's the first term or adding something. So adding a negative number or adding a positive number. So basically, to get the next one, A1 is given. So this is given, right? Now A2 would be A1 plus some number. We call that a common difference. Well, we're going to look at it in a second. And then A3 would be what? Would be A2 plus D, and so forth. If that's the case, we call it an arithmetic sequence. Now, the way you find that number that has been added, whether it is positive or negative, is to subtract the pairs of numbers that we are given here. If you subtract them, you get that number. See, 6 minus 3, 3. 9 minus 6, 3. 12 minus 9, 3. 15 minus 12, 3. So that's called the common difference, and we call it D. So that's how we get the terms of a arithmetic sequence. Now notice that another way to write this is, you see, A1 is given, but A2 is what? A2 is A1 plus D, and A3 is A2 plus D, but we know A2 is A1 plus D, right? And then plus another D. So that's A1 plus 2D. And then A4 is going to be A3 plus D, but we know A3 is what? A1 plus 2D, and then another D, so that's A1 plus 3D. So you see the pattern? The second term, I have to add 1D to it, to the first term. The third term, I add 2Ds to the first term. And then A4, I have to add 3Ds to the first term. So it looks like the general formula is always A1 plus what? How many D's? N minus 1. So A sub 3 would be A1 plus D times 3 minus 1, and so forth. So this is a recursive formula for what? For arithmetic sequence. Okay, so let me show you some examples. Are these arithmetic sequences? Well, let's see, 2 minus 1, 4 minus 2, that's 1, that's 2, 8 minus 4 is 4, no, because the differences are not the same. 1 minus negative 3, 4, 5 minus 1, 4, 9 minus 5, 4, 13 minus 4. So that's the common difference. So we can write it actually recursive formula for that. A sub n equals to, what's the first term? Negative 3 plus what? What is D? 4 times what? N minus 1. So that's a recursive formula for that. But if you're given this, you can actually convert it to explicit formula. If you're given this, we already know what A1 is, right? So we can actually, give it an explicit formula. All right, so here is the answer. I already talked about it. Let me clean this mess. Okay, and we can graph it. If you graph an arithmetic sequence, you see the points are on a straight line. It's just like the function, except that between the integers you have to empty spaces because we're not going to find function values for those spaces, right? All right, so here is another one. Write the first 5 terms of arithmetic sequence. A1 is 17 and D is negative 3. So if you think of A sub n be A1 plus D times n minus 1. So what do we have here? We have A1. So here we have A sub n is 17 plus, we need D, we have D, so it's negative, I just put negative 3, n minus 1. So that's the formula, and this formula can give us all the other members. If you start with 17, the next one is when you put 2 in here, right? So this formula is good for n greater than or equal to 2, because when n is 1, we already know what A1 is. We're not going to use this formula, right? I mean this formula. But here, of course, we can even use, if you convert it to a explicit formula, you can even use when n equals to 1. So here we say n is greater than or equal to 2. But over here, we can say n is greater than or equal to 1, because we already know what A1 is here. So if I put a 1 here, this becomes 0, so we just get the first term, right? Put 1 here, you get the first term. So if you don't know what A1 is, you can use this But if you know what A1 is, you can actually simplify this, right? We get 17 minus 3n plus 3. So A sub n is 20 minus 3n. So put different numbers for n and then you get the terms. When n equals to 2, we get 20 minus 6, 14. For 3, 20 minus 9, 11. Okay, and so forth. Again, you can use calculator. And I did with base given, so I didn't simplify it to explicit formula. I just used that. So put 17 and I got the numbers. All right, so let's move on. Given A1 equals to that and A4 equals to that, find A5. So we are given that, so we know A sub n is A sub 1 plus d times n minus 1. So what are we given here? We are given A sub 1. So here we go, let's put it there. So that much information we have. Then we are given that A sub 4 is 14. That means if I put a 4 here, this would be 14. So A sub 4 is going to be 14, which is equal to 8 plus d times what? Well, you remember it's A sub 4, so n has to be 4. So that means 14 is 8 plus 3d, right? So 3d has to be 14 minus 6, minus 8, which is 6. So that means d is 2. So we got d, and we got this formula here. So the formula, now we have a complete picture of what's going on here. There. That's the formula for this arithmetic sequence. Now we can find A sub 5 or A sub whatever because we have the formula. So we just put 5 here for n. See, you can also call this f of n, right? That's another name for it. So put a 5 there, the answer is 16, right? So I'm going to clean this and then you can look at the work here. That's the same thing. All right, recursive formula for arithmetic sequence. It looks like that, of course. If you leave it like that, it's recursive. So if I do it this way, and you're given A1 is not recursive, but if I leave it like this, that's for sure is recursive, right? Because A sub n depends on what? A sub n minus 1. That's recursive. This formula probably, maybe we shouldn't call it recursive because we are given A1 plus what? D times n minus 1. This really, if you're given this, you can just simplify it. And that would be actually dn minus d, and then you get an explicit formula. So let's call this explicit. Let's call this recursive. All right, so that's recursive. So what do we want here? Find a recursive is the easiest thing to do because all you have to do is what? Find your d. That's all we need. So to write the recursive, all we need is d. We don't need a1. Right? A1 is given. So what do? We subtract negative 7 minus negative 18, and we can find our d, right? So our d is 11. So this is the formula. Just put 11 there. Of course, well, let me do that. If I put 11 there, well, that's not going to give you the term. So what is missing? You have to have A1, right? So recursive, you always have to have A1. Otherwise, you can't start. Where do you start? Once you have A1, then this formula tells you what to do. All right? Now if you want, let me do that too because I don't want it to be confusing. So that would be plus 11, right? Now, since we know A1 and we know D, we can write explicit formula for this. We can just write negative 18 plus 11 times what? N minus 1. That would be explicit formula for that. All right, so let's move on. An explicit formula for nth term is this right here. And so how do you write the explicit formula? For explicit formula, we need A1, which we do have it, is right here. And then we need what? We need D. 12 minus 2, 12, 22 minus 12, 32 minus 12, 42. That's 10, right? That's it. That's the explicit formula for that sequence. All right. And find the number of terms in the finite arithmetic sequence. So we're given a sequence, there is dot, dot, dot there. We don't know how many terms are there. So what's the position of that number? The position of that number is the n that we substituted in the formula to get that. But we don't know that. So what do we need to know? We need to know the formula in order to find that. The formula is, well, let's put D times n minus 1, right? So let's write the formula. What's the formula? Well, A1, obviously, you see it there. And what is D? 1 minus 8 is negative 7. Negative 6 minus 1, negative 7. So D is negative 7. So why don't we put negative 7 here? That's the formula, explicit formula for that. Now we're going to say, okay, what n gives us negative 41? So you have to put negative 41 here and solve for n, right? So this is a linear equation, you can solve it. So let me show you what we get. We get 8, right? If you put negative 41 there and solve, you can simplify this first and then put negative 41 on the left. So n equals to 8. So that means if this is n equal to 8, then there are 8 terms because you start from 1. 1, 2, 3, 4, 5, 6, 7, 8. A woman decides to go for a 10-minute run every day this week and plans to increase the time of her daily run by 4 minutes each week. So write the formula for the time of her run after n weeks. How long will her daily run be 8 weeks from today? Okay, well, again, the formula is going to be a sub n equals to a sub 1 plus some d times n minus 1. So here we have a sub 1 is what she starts with, which is how much? 10. Plus, and how much does she add every day? 4 minutes. There. And then it says, how long will her daily run be? 8 weeks from today. So week number 8, right? This is first week and start today. Second, third, fourth, fifth, second. 1, 2, 3, 4, 5, 6, 7, 8. So at that point, we just put n equals to 8. And the answer is 38. And then instead of a sub n, you could call it t sub n, time at position n. And n is the week number 1, week number 2, and so forth. All right, let's talk about another type of sequences. It's called geometric sequence. In geometric sequence, instead of adding, we multiply. So let's say I start with 2. And I keep multiplying by 3, right? If I have a sequence like this, it's not arithmetic, obviously, You see the difference here is 4 and difference here is 12, so it's not arithmetic, so it's geometric. So if you start with some number and keep multiplying it by a number, doesn't matter, it could be any number, negative, positive, real number, right? So let's say in this case I multiply it by 2, right? So I start with a1, which is 2, and I keep multiplying it by what? By 3. So 2 times 3 gives me the next term. And then the next term would be 2 times 3, which is 6, and then times 3 again. So it would be 2 times 3 times 3, second term. Third term would be 2 times 3 times 3 times 3. So it looks like all I have to do is this. A sub n is a sub 1 times r, but not to nth power, because to nth power, the first term will never get 2 if you want the first term to be 2, because n equals to 1 will raise the 3 to the first power, you don't get 2. So we have to put n minus 1, right? Then this, when n equals to 1, would be, so let's put the numbers here. So it would be a sub n equals to 2 times 3 to n minus 1, right? So that's the general formula, which is actually what is explicit. If you're given a1, that's explicit formula. So n equals to 1, then it would be 3 to 0th power, which is 1. 1 times 2 is 2. Get the first term. When n equals to 2, you get 2 minus 1 is 1. 3 to the first is 3 times 2 is 6, and so forth. So this is called geometric. Let's look at some examples of geometric. For example, if somebody starts with a salary of $26,000 and then supposed to get a raise of 2% every year. So the next year, the salary should be this much plus what? The next should be this much plus this much times the rate, which is 0.02. So how do we get the answer out of here? Well, we can do this with the calculator, but think about it. They both have 26,000. We can factor 26,000 out. So this, think of it, there's a 1 here, and there's 0.02 here. That would be 1 plus 0.02. So if you multiply 26,000 by this number, you get the next year's salary. So that means our R here is 1.02. That means the formula for this is just A sub n is start with 26,000, and then R is 1.02, and raise it to R minus 1. N minus 1. N minus 1, right? So if you put n equal to 1 here, 1 minus 1 is 0, so this becomes 1 times 26,000, you get the first term. And the next would be this times that. And the next would be this times this to the second power, and so forth. Okay, so that's the idea of a geometric sequence. And it looks like this. So first term is a1, second is a1 times r, and then a1 times r squared, and eventually you get that formula. Now, when you take the numbers, let's say I keep multiplying by 3, right? So I get 6, 18, and so forth. Now to get the r, which is called common ratio, you just divide the pairs. 6 divided by 2, 18 divided by 6, right? That's how you get the common ratio. So once you have the common ratio, then the formula is obvious. It's multiplied by r to n minus 1, and r is that number. Okay, so are these geometric? Well, we divide. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. Yes, this is geometric. And the common difference is, common factor, ratio, what am I saying? Common ratio is 2. And what about here? Well, if you divide, you see that this one is not, because 12 divided by 48 is 1/4. 4 divided by 12 is 1/3. 2 divided by 4 is 1/2. So we don't have the same ratio, common ratio. And ratio could be a fraction, it could be a negative number, right? So here, list the first 4 terms here. Well, we can do that. It says A1 is 5 and R is -2. So you start with -2 and keep multiplying by what? By 5. So that's -10 and then negative 2 actually. What am I doing? So we start with positive 5 and keep multiplying by -2. So we get -10. -2 times -10, 20. -2 times 20 is -40 and so forth, right? So we get this alternating thing if our R is what? Is a negative. And so how do we write the formula for this? Would be A sub n equals to, what's our first term? 5. What is our R? -2. And then n minus 1. Right? So that is the formula for geometric series. So these are the terms, right? All right, so let's see what else we can do. So that's the formula I just talked about, right? It's a recursive formula. Now, the formula I just talked about was explicit because you basically what you do is you take that and then if you know n, you know all the terms, right? Because this is A1. When n is 1, you get A1. But recursive formula would be A sub n depends on the previous one, which means that you take R and multiply it by previous term. So that's recursive and that's the explicit. So here it says write a recursive formula for the following geometric sequence. So to write the recursive, all I need is R, right? And I need A1. So this formula right here, it goes with the information that A1 has to be what? Given. Otherwise, we can't start this process. And n is greater than or equal to 2. Here, n is greater than or equal to 1, and you don't need A1 because A1 is in the formula right here. The other way around. I thought the bottom one was recursive. So this one, you need to have A1 given, and n is greater than or equal to 2. Here, n is greater than or equal to 1, because when n is 1, you have A1. So recursive, explicit. So what do I need? Well, all I need is R and A1. A1 I have, 6. And 9 divided by 6, this divided by that, and looks like it's 1.5. So that's the recursive formula. All right, so let me clean this up. The nth term of a geometric series is given by explicit form. This is explicit, right? Talked about that already. Given a geometric sequence with that and that, find A2. Okay, so let's use this formula. A sub n is A1 R to n minus 1, right? So A1 is what? A1 is 3, and our R is missing, right? We don't know what R is, and we know n minus 1 here. That's so far, just knowing this, right? But we have another piece of information, that A4 is 24. So A4 means when n is what? 4. So when n is 4, what do we have? A4 is 24. So you can put 24 here equals to 3 times r to 4 minus 1, right? Because that's a sub 4. So that is 3r to the third power, which means 24 equals to 3r to the third power. That means r to the third power is 8, 24 divided by 3. And r is 2, right? So our formula is a sub n equals to 3, 2 to n minus 1. That's a complete picture of this geometric series. I mean, sequence. I keep saying series is sequence. All right, so let me show you the answer and oops, no, just a moment. And we didn't find what? We didn't find A2. We found the formula, but let me show you the answer. So once we have the formula, right? So we have the formula, which is 3 and then 2 to n minus 1. And we can find a sub 2, which is 3 times 2 to 2 minus 1. So A2 is 6, right? All right. Write an explicit formula for the nth term of the sequence. Okay, for explicit formula, again, what do we need? We need A1 and we need R. A1 is given, is 2. R, we don't know, but we can divide. 10 divided by 2, this divided by that, this 2, so it's 5. So 5 to n minus 1. There. That's the explicit formula for this geometric sequence. Okay. I'll let you look at this and make sure you got this under control. All right, business starts a new website. Initially, the number of hits is 293 due to curiosity factor. The business estimates the number of hits will increase by 2.6%. Again, that means R is 1.026 per week. Write a formula for number of hits. Well, that's easy. A sub n would be, what's A sub 1? 293, because we start with that, right? And then would be R, which is 1.026 to the power of n minus 1. That's the formula. Again, how do we know R is that? Because we start with 293, and the next number has to be 0.026 more than what? More than 293. That means the next number has to be this sum that goes there. But this sum is what? Is 293 times 1.026. So to get this. So that makes our, right? Because that would be 1 plus 0.026 if you factor 293 out. So that's 293 times 1.026. So that's our R right there. That's why. All right, so now that we know our formula, we can just put what? Put 6 in there, right? Estimate the number of hits in week 6, so you just put 6 there. N is a week number, right? All right, so that is 333 approximately, right? All right. So what I'm going to do is another video for the rest of this chapter, okay? So for now, I'm gonna maybe stop right here and go back to our, here we go, say bye to you and take care of yourself. I'll see you in the next video.